We are living in the era of data. Data-driven decision making is the key. Business intelligence and data analytics tool is driving that decision making. One of the most important place where the data is stored is today's date, especially the structured data is stored on databases or what we call relational database management systems. And these relational database management system primarily use SQL to retrieve the data. SQL is there for quite some time now. Databases are there for quite some time, and it remained the relevant skill for decades. As a data engineer, as a business intelligence architect, you need to have good understanding of SQL, because most of the time in an organization, we will be using some database or other to get the data. Data transformation can be done easily on SQL compared to all other technologies. So having SQL in your skill set is really important, and some of you were asking me to start a series on that. So in this new year 2023, the wish is coming true. I am starting with a series on SQL, and we will be learning the SQL using SQL Server Express Edition. There would be certain difference in few places with other databases, and as time permits, I will be covering those whenever is possible. So let's begin our journey. Journey will begin with concepts. We have a lot of concepts around it. We will try to cover few of them. So first, we will look what database, DBMS or RDBMS is. The term database management system or DBMS refers to a system for storing and organizing data on a computer. Charles W. Bachman designed the navigational database system in 1960s, and this is considered as first database management system or DBMS. So that navigational system was the starting point for the DBMS. Now, DBMS stands for database management system. It is a software application that is used to create, manage and manipulate databases. An organization of data, tables or fields is referred to as a database. Users can access, edit and create databases using DBMS as well as control access to the data. Users of database management system have to access a variety of functions that enable them to manipulate the data in databases or manage all aspects of the database structure themselves. So database make sure that the access of the data, the edit of the data become easier. What happens prior to database, the entire control was in the hand of the developers. So what happens, you have a file system where you are writing, the developer itself every time is writing down the code for insert, update and delete, and think at one place he make a mistake. The entire code could go for a toss. So every time you have a lot of testing whenever you are modifying that program. But what database management system has done is they had ensured that there is a common platform available which can ensure this insert, update, delete operations, create, update, edit. These operations are streamlined and you don't have to bother about these basic operations. Only thing you have to bother about the business rules, your constraints. So that's where the DBMS are so popular. And then comes the RDBMS, Relational Database Management System. The term RDBMS refers to Relational Database Management System. As the name implies, a relational database is a type of database that is based on relations that exist between the elements that are stored within the database. This type of database allows user to establish link between the set of data combined with the database. In addition, it allows users to manage and reference data within the database. So relational database, there are relationships which is within the entities, especially tables. Now we can call in one of the table, this is the primary key, and then in another table we can call foreign keys, and the database will make sure that the foreign key have all the values which primary key have. Let's say you want to have a entry done in the sales table for an item. Database is going to ensure that that item exists in item master. Then you can define certain rules, constraint. Database will make sure those constraints getting applied. So RDBMS is one which is primarily used these days. Let's go into more details of that. A set of rules developed by Edgar F. Codd that defines the characteristic of a true relational database management system, RDBMS. Accord rules ensure that the RDBMS properly implements the relational model and is able to provide all the benefit it was intended to provide. See, RDBMS is the key. Since its model has been proposed, there are many RDBMSs are there, and these RDBMS holds most of your organizational data, and SQL is key to access that. So RDBMS is the basis for SQL and all modern database systems like MS SQL Server, IBM DB2, Oracle, MySQL, Microsoft Access, SQL Server, all allows you to have a SQL access on the databases. We have the cloud databases. Now the era is of cloud. We have like Azure SQL, we have Cosmos DB, all these databases, we will be able to use SQL. And even modern technologies like Spark, they allow Spark SQL. So that is the power of SQL. See, SQL is even there on the systems which are not initially designed for those purposes. And because it is so easy to manage the things using SQL, that we have SQL access for all these new technologies also. Let's continue with RDBMS. The RDBMS has changed the way we store and retrieve the data. The RDBMS has given us the power of data discovery. They have enabled us access of data easily and quickly, which has led to development of management information system, business intelligence system, and business analytics system. Now these RDBMS for modern business intelligence system could be a little bit different. Like, typical RDBMS are the row-based RDBMS system, where you store the data in row. We do have columnar databases. Then you will hear the term about distributed databases, the databases which can occur more than one machine. Now this distribution can enhance your performance. Now the database can be distributed as well as replicated. So what's the difference? When you distribute, let's say I have a table which stores the data, I distribute it into the 4 servers. It is not replication. I dividing the same data at 4 places so that I can quickly retrieve it, the 4 systems, and combine and give you the result. But then there could be a replication, so that let's say these 4 things getting replicated 3 times. Now one of the 3 things can read it and give it to you the results. So distributed and replicated hyper performance databases. So these kind of combinations are possible in modern era. RDBMSs are widely used because they provide number of benefits, such as ability to easily retrieve and manipulate data using structured query language SQL, as well as ability to relate data stored across multiple tables based on foreign keys. So RDBMS, whenever we are talking about SQL also. So there are 12 rules which Codd has given, which are very famous, and let's look at those rules. Now, to have a greater understanding of database, we should understand these rules. Now, most of the database are going to take care of these rules, but we should be knowing what these rules are. So the information rule: all the data in the database should be represented in logical and organized manner, independent of the application program that are used to access the data. So that is the information rule. The guarantee access rule: all the data in the database should be accessible using straightforward high level language. Okay. So data should be stored in organized manner, and it should guarantee the access, easy access. The systematic treatment of null values. Null values, either value that are missing, should be treated in systematically and consistent way. Means null values should be treated, and null values in database is going to be a little bit different. Those of you are working on the business intelligence tool, there the treatment could be really different, but null value is something which is missing. It's not present, and it is not equal to 0 or not equal to blank string or 0 length string. It's not same. It's the missing value. And we have, like, when we learn SQL, we will learn something like is null, is not null, special ways to handle the null values. Now let's look at the next set of rule. The active online catalog. The database should include catalog that describes the structure and the content of the database, and this catalog should be accessible to the users and application. What is stored in the database, what tables, what columns, all these should be available. The comprehensive data sub-language. The database should include a comprehensive data manipulation language such as SQL that is capable of performing all necessary data manipulation operations like insert, update, delete. These kind of operations should be easily be able to performed on a database. Then we comes to the view updating rule. The database should support the ability to create and manipulate views, the virtual tables that are derived from the data in the database. So the views should get updated. These views should be simply the views, or these could be materialized views or something where the data can get updated. The high level of insert, update and delete. The data manipulation language should support the ability to insert, update and delete data in the database. So the basic operations which are required on a database is insert, update and delete. So a high level of that should be maintained by the database. The physical data independence. The database should be designed in such a way that the changes to the physical storage of the data, such as hardware or storage media, should not affect the logical structure of the database or the application program that accesses. It means I should not be bothered about what hardware, what storage media. I should be able to access independently of that fact. The logical data independence. The database should be designed in such a way that the changes to the logical structure of the database, such as addition or removal of tables or field, should not affect the application program that accesses it. It should not happen that some operation is going and the other program is getting impacted. No, that should not happen. So physical independence is also required. Logical independence is also required. The integrity independence. The database should support the ability to define integrity constraint, rule that ensure the consistency and accuracy of data, and enforces these constraints automatically. We don't have to write explicit code. There should be, mechanism available to define these integrity and integrity constraints. Then comes the distribution independence. The database should be able to support distributed processing. Means the ability to access and manipulate data across multiple computers. Means it is not necessary that data is going to lie on one computer. It could be lying in multiple computers, and database should be able to take care of that across multiple computers the program runs smoothly and user is not impacted. User don't have to do anything special. He just write down the same select statement and get the result. So let's say I have a table 1. I said select star from table 1. It gives me all the rows from the table 1, whether I am having the database on one system or the database is there on multiple systems. It should not make any difference. The non-subversion rule. The database should not allow users or application program to bypass the database management system and access the data directly. So it means that database management system should take care that directly you can't read. It should not be like a file where you go and you edit and you write down whatever you want to write down. The only mechanism is going via the database. You log in into the database, you go, you write down SQL, you run update statement, or you write down some program which can access the database using the credentials, and those program can update. So direct updation on the file system, that should not be possible. So these are basically the rules which we have. Now let's go into further more concepts. Let's understand few more database concepts like tables, columns, record, etc. So what is a table? Data in a relational database management system is stored in a database object called table, which is essentially a collection of related data entries arranged in column and rows. A table is basically an object, an RDBMS, that consists of various columns and rows. So this is an example like item table, but we'll have an item ID, we'll have a name, we'll have a brand ID, category ID, subcategory ID, brand category and subcategory. So table is like that. So what I've done is I have, have an Excel here. Now if you look at this Excel, in this Excel I have the same table. Now if I load it to a database and I create an item table, and which we'll be doing at some stage later, then what would happen? We will have a table with item which contains this kind of data. We'll have columns and we'll have rows. So these are basically columns and these are basically rows. Rows contain values for various columns which we have in the table. There could be null values or blank values that could be also be there. So that's the table for us. Now what is a field? A table consists of number of fields. For example, the item table consists of item ID, name, brand, category and subcategory. The table is broken down into smaller elements called field. A field is a column that contains specific information about each record of the table. What is a record or a row? A record is also known as row of the data in the table, and that refers to the individual entries that are contained within the table. We have explained you, just have another look. So this is what we call as row and this is what we call as column. The field is item ID, name, brand ID, category ID, brand, category and subcategory, etc. Now what is a column? Column are vertical entities in the table, contains information related to each field. For example, and column in item table is name. So name, and typically what happens that all the values in a particular column will have the same data type. They cannot have different data types. All of them will have text, all of them will have numbers. A record can have different data types, but a column typically will have similar kind of properties. It has name, it will contain all the name. It is age, and data type would also be same. Age is integer, then it's all going to be integer. Name is text, then it is going to be text. Okay. Now in modern databases, you do have JSON field which actually can contain, JSON files which can actually contain multiple fields. That is a different thing. But the behavior is like all of them will contain a JSON file. Then what is null value? The null value in a table refers to a value in the field that appears to be blank, which means that field with no value. Therefore, the null value in the table represents a field without any value. The concept of null is very important to understand, as it does not mean the same thing as zero or space in the field. A field with the null value indicates the field has been left blank during the process of creation of a record. While you were creating record, you did not inserted it. That's what the null value. It is not equal to zero. Some databases you will find it is equal to zero or blank space. That could be exception like that. But ideally speaking, it is not. So it's not null. It's not equal to zero. It's not equal to space. It's not equal to blank string. No, any of those things is not null. It is the value which has been left out, is not being filled. That is blank or null here in the databases. Then we comes to something known as SQL constraints. A constraint can be applied either at a column level, means we can have certain rules for the column, or at table level, we can have a table level rules. Column level constraints are applied to only one column, where a table level constraints are applied to the whole table. The constraints are not null. This constraint ensures that column cannot have a null value. So if you define a null, not null, then it cannot have a null value. Unique. Make sure that all the values in the column are different from each other. But in case of unique, you can have one value as a null value. Primary key. It identifies the row of the database table uniquely as row or record in each table. So every value would be unique. So let's take this example of item table. If you look at item table, item ID is unique. It's primary key. Now in case of unique, I can have a null item ID. Means one of the unique value can be null. In case of primary key, it is not. You cannot have a null value. So all the values are unique. One is not repeating. See, in this case, brand ID, category ID and subcategory ID are not unique, nor they are primary key. They are keys. They can be foreign keys if the separate tables are created, but they are not the primary keys or unique keys. The item ID is a primary key or unique key. Okay. Foreign keys. Identify the rows of the record in another database table in a unique manner. Now what happens, item ID is here in the item table. I have a sales table also. In the sales table, I also have an item ID. Now this item ID is a foreign key here. Now database is going to ensure that there is no value in this table sales which does not exist in the item table. Whenever we are inserting, it has to be ensured. Referential integrity. That a foreign key cannot have a value for which there is no primary key value available. So item ID in my sales table, which we are going to load and make it as a sales table, should exist in item table. And it's a foreign key here because there is somewhere else it is a primary key. Check. Ensures all the values in a column meet certain criteria. Like we can say age should be greater than 0. Integers. Age is integer, but it cannot be less than 0. It cannot be negative. Or we can say, let's say certain data should be within the range. Or in the text, when we are writing down name, we don't want to allow the numeric, because in the text you can write down alphanumeric characters. We can have so many types of checks. Default provides a default value when there is no value specified. Sometimes what happens, let's say when we are defining groups, categories, we want, some value or other value to be present. We don't want null values. So we say if the user is not entering, then default it to some other value. So using the default value, you can ensure that there is no, null values entered into your field, and sometimes it is easy to handle such things. And also those become optional for user to enter, like if there is a default value available and if user doesn't want to enter, then user can simply enter lesser data. Now then there are data integrity constraints. So data integrity categorize exist with each RDBMS. Entity, like entity integrity. The table should not contain any duplicate rows in it. Referential integrity. The record that used by another record cannot be deleted. So example, like, let's take an example. Let's say I want to delete item ID 1 here. I can't delete it because it is used by sales table. So first I need to remove all the records in the sales table having the item ID 1, and then I should be able to delete item ID 1 in the item table. Domain integrity limits type, format or range of the values to ensure valid entries given in a given column. So in the column we push the domain integrity, what kind of type, what kind of format, what kind of range, and all those. User defined integrity enforces some specific business rules related to entities, domain and references. So some user defined rules could be there. Now what happens when we are doing these databases? We would like to ensure the database data is stored in a proper manner. And there is a process known as database normalization. This process is going to ensure that the data is not redundant and it is easy to maintain. So the entire objective of the normalization process is to make sure that the entire process of managing is efficient. So the database normalization is the process of efficiently organizing in the database. There are two reasons for normalizing process: eliminating the redundant data, for example, the storing the same data in more than one table, ensuring data dependencies make sense. Both these reasons are worthy goal as they reduce the amount of space database consumes and ensure the data is logically stored. And I'll give you an example. Like this item table right now is not normalized in our case. So if I go here in item table, look at this. The brand and the brand ID is there and brand is also there. What happening in this case is unnecessary all these brands are there. And if this brand changes the name, what I need to do is I need to make sure that I update all the records. So I end up updating all these records. Instead of that one, if I would have another table where I would have this only brand ID. So let's do one thing. Let's try to have this data copied. Let's see if we can copy it together. Let's create a new sheet, paste these. delete these unnecessary stuff from here. And now let's see if we can remove the duplicates. Now this is not the manner we are going to create in database. I'm just showing you an example. So we have data, and under the data we should have an option for remove duplicates. Yes. So now ideally what should have happened here is the item table should not have this brand. I should have a brand table where I should have brand ID and brand. And whenever needed, I can join this item table with the brand table. And in that manner, this database would be normalized. Same would happen for category and subcategory. Now what happens anytime I want to modify the brand 10, let's say I want to give it brand 10 a different name, I need to only modify one record. Here I need to modify multiple record. And this could have not been item table. Maybe I have a bad database structure. I might have brand in the sales table also. What happens if I update the item 10, brand 10 in the item table and forgot to update in sales table? Somebody can query something different in sales table if they don't use the join with the item table. So these are the reasons why we normalize our table and keep on creating. So what would happen? Item table will be broken further into brand table, and then we will have a subcategory table where we will have a subcategory ID, subcategory name and category ID. And then further we will have a category table where we will have category ID and category. So that is how our structure will become once we start normalizing this data. So this table itself will be converted into 4 tables. Okay, so let's move further. Normalization consists of a series of guidelines that help guide you creating good database structure. Normalization guidelines are divided into normal forms. Think of a form as a format or the way database structure is laid out. So we have first normal form, we have second normal form, we have third normal form, fourth normal form, etc. The aim of the normal form is to organize the database structure so that it complies with the rules of first normal form, then second, then third, and finally the third normal form. And it's your choice to further take it the fourth normal form or fifth normal form and so on. Typically, a good database is usually a third normal form database. Fourth and fifth are rarely used. BCNF we also called boycott normal form in case of the fourth normalization. So that is something which we can use. Okay, so this is little bit about normalization. We will come back and discuss the normalization once again when we will have the tables and we want to convert it into the normal form. We will take these examples and talk about what is the first normal form, what is the second normal form, and how to do that. That we will do over a period of time. Now time has come that we learn little bit of SQL first, and then we come back to some of these concepts. Now the choices which you have is you can have the database, and each database will have a studio, a preferable studio. It doesn't mean that there are not common studio and some of those cannot access other databases. So if you want to go with SQL Server Management Studio is the best one. And SQL Server Express is freely available. SQL Server Management Studio is also freely available. If you're going with MySQL, there is an open source version for MySQL, and then there is a MySQL Workbench also available. Similarly, Oracle have an Express edition. You can use Oracle Express edition, and you can have also SQL Developer used for that. Now for PostgreSQL database, you have an open source version, and PG admin is something which you should be using. So all these 4 databases, these are the commonly used, and for your choice, you can go and have look at other databases. But what we are going to do for this particular series, we are going to use SQL Server Express edition, and we are going to use SQL Server Management Studio. These things are already installed on my machine, but I'm going to tell you from where to download and install it. I'm going to show you a little bit of steps so that you can download and install these. And once you are done with that, then come back to this video where we will be, login into the SQL Server. I'm also going to tell you how to stop this on Windows. So right now what I'm doing, I'm having a Windows machine, so I'm going to install it on Windows. But some of these databases can work on Linux and Mac also. Check out with each and every database which one works on which machine. So like and based on that you can install. There could be a little bit of difference in each database is what we are doing, but what we'll try to do is basically initially whenever we are creating certain things, we will try that we use little bit generic data types so that you don't have to bother too much around initial stuff around the data types and all those. Now when we create a table, we will have a column will have a data type. Now the data type can differ from database to database. SQL server, it may be called differently. MySQL, it may be called a little bit differently, but we will try to have pretty common data types which are really common, like integers, numbers and all those, so that we can make sure that you are, even if you are not using SQL Server Express Edition, you'll be able to do that. So let me open my browser and tell you how to download SQL Server Express Edition and Management Studio. So my browser is open and let me search for SQL Server Express Edition, and once I do that, I'll get the link for SQL Server Downloads Microsoft. This is the first link, and if I scroll little bit, it will show me about SQL Server on Azure. And if you wanted to know how you want to establish a Azure SQL Server, you can watch my Power BI series. There I have shown you how can you have SQL Server on Azure and how you can utilize that. So you can go ahead and watch that video. Now SQL Server Developer is fully featured, free edition, licensed, as used as development test database for non-production. You can download this one, or I'm going to download this Express Edition because this is free and ideal for deployment and production desktop, web, small server application. So I'll say download now, and it will start downloading. Once it is downloaded, I can double click on it and install. But before I do that installation, let me tell you about the second software. The second software is SQL Server Management Studio. Again, you can download the latest version, or you can even download one before version. Click here, free download for SQL Server Management Studio, and click here, and then it will also download. It will take certain minutes. Now those of you who are looking for Oracle or SQL developer, you can say Oracle Express Edition, and you might require a login to be created in Oracle environment. So Oracle might ask you to create a login for that. You can say download the Oracle Database XC, and then similarly you can say SQL developer, or we can say Oracle SQL developer, and you can download the Oracle SQL developer. Again, you might require login on the site. It requires a JDK, and if you don't have JDK, you can install the one which include the JDK in it. So that you can do. For MySQL, you can search for download MySQL. Then you have to search for the community server. Okay, and then you should be able to download this is the enterprise MySQL community GPL download, and then you can go and MySQL community server, and then you can download the MySQL community version and install it. Similarly, MySQL Workbench, download the MySQL Workbench. Again, you will get the link. MySQL Workbench 8.2.31 is the latest one right now. You can download that. Now, some of these software while installing may ask you latest version of JDK, or some may ask for latest version of .NET. So make sure your Windows is up to date and have those things which they are asking. Some people faces challenges with SQL Server 2019. You can find out SQL Server Express Edition 2017 and install that in case you face some issues. Now let's look at PostgreSQL also. So let's look for PostgreSQL, and let's download that. You have choices which you want to download. In case I have to install, I'll download the Windows, and similarly search for PG admin download, and you will get a link for PG admin, and you can download that. Now, so every database has a best studio to connect. I have shown you all the 4 of them. You can search and download and I'll also try to provide those links into the description in case you are unable to search that quickly. You can use those links. Now both SQL Server and SQL Server Management Studio downloads are completed. I can click here and start this one. It is asking for permission. Once I give the permission, it will check it out. I can say basic or custom. I'll say basic and proceed further, and it will ask me to accept the license agreement, which I can accept. It will ask for the location. I can give the location and say installed. I already have the SQL Server installed, Express Edition installed, so I'm not going to go ahead with it. Make sure you have the minimum free space, and this is going to download right. These days what happens is they typically don't download the complete file. They actually download a small file, and then once you start double click on that, they will download the complete file and then do it. So click on the install and proceed further. It should install. It should not ask you much of the information. At the end, it is going to give you some information that you copy paste and keep it with you, so that information would be useful. Also, it will open a SQL prompt for you, which you can also utilize to, run some queries or create database. Now let me close this and let me open the SQL Server Management Studio installer, and I say yes. Again, I've given the permission. So right now it is asking repair, uninstall and close, because it has already detected that I have a SQL Server Management Studio installed. In your case, you will be installing, you will give a location, and once you give the location, you should be able to install SQL Server Management Studio also. Now what I'm going to do here is I'm going to open the Windows services.msc. You can put that command into the run and open that file. So let me open services.msc. So I pressed Windows R and it will open the Windows services, and there I'll go search for SQL Server Express Edition. SQL I typed, it reaches there. Why I kept it closed? Because what happens once you install these things, and if you have little bit challenge with your RAM, then these things may slow down. So what I typically does it, I keep it closed. However, I made it automatic. Whenever Windows start, it should start, but you can change that setting from the properties to not to start automatically. You can keep it manual or delayed start. At least it should not start at the startup. So should not, your Windows might not load fast if it is started automatically. Then what you can do is whenever you need it, you can right click and say start. And once your work is done, you can right click and say stop. So you can come to services and you can start and stop your SQL Server. If you start Oracle, same thing, MySQL and PostgreSQL, you can do for all of them. Now time has come that I should open SQL Server Management Studio and show you what is lying there for us. So what you can do is you can search for SQL Server Management Studio and open it. And in SQL Server Management Studio, we'll try to log in and create a database. And for today's tutorial, before we end, we'll just like to create a table also. So what I'm going to do is on the SQL Server, because I keep on using it for multiple purpose, you have to set it to database engine. You can say localhost /SQL Express, or you can simply say local. And by default, the Windows authentication would be enabled unless you disable it. So you can use that. And I'm going to use the Windows authentication for the SQL Server. I'm not going to create anything else. And once it is open, you will get something like that. Now, when it is first time, you will not have any databases. I have databases because I already created one. So what you have to do is you have to right click on a database and you have to create a new database. Now, new database, you will say learn SQL. You can give some other name, but I'm giving learn SQL. And if your drive have the space challenges, you can choose whatever place. You can actually choose location for both the files. So choose the location, whatever you want. And even you can change the file name here. Okay. Then there are certain options. Right now we'll keep all of them as default only, but you can change, like, recovery mode is simple. Keep it simple because otherwise your log file would be too heavy. Compatibility, what should be there? It is 150. There are certain things which has came in 160. For that we might have to install the development version, and then you can have the file groups and all those if you wanted to have that. But right now we'll keep them default, and whenever we progress further, we will learn more database things. We will come to the management part and we'll learn more things. Right now just take care that whatever drive you wanted to save it. I usually don't suggest it to keep it into the program files, because if you want to move it, you should have it at some other location than program files so that you can easily access it. So change that, put it somewhere where you wanted to have it. So but right now I'm keeping that default, and I'll say okay. So my database is going to be created, and once I open this database button, I should be able to see the Learn SQL, and I should be able to say right click new query. Once you open this new query, this is the place where you can run the queries on the database. Now I can further click on this database and check out what tables I have. Right now I don't have a table, so that is why it is not showing me any table. Now before we wrap up today's session, let's quickly create a table, insert some data, and just select it and check it out. Option of create table. So create table, so we have create table, update table, delete and select statement, but right now our focus is simply create a table, insert few rows and select it and check it out, and then we will go into the details of each and everything as we progress. Now this is the syntax of a table. Basically create table, table name, and then we start the parenthesis, and then within the parenthesis we start giving column name and the data type, and then there are optional like not null. You can specify if it is not null, then it will not allow null value. You can say it's a primary key, then it will not allow to insert any duplicate values. Then at least one column name is required, then you can have another column name, data type, and the constraint like not null, primary key, all those things you can have. You can continue to give the column name as many as you want, which are allowed as per the database, and then at the end you have to close the parenthesis. After that there is a semicolon. Now if you are working on like SQL command prompt, then semicolon act as the command ending. So once the SQL prompt see that there is a semicolon and you press enter, then it says execute the statement. Now in studios that doesn't happen, we have to select and execute the statement. But yes, if you are executing multiple statements, semicolon do act as a separator of the statement, and most of the databases does support this as a separator. So let's quickly create a table here. Create table demo. So create table, table name is demo, and in the table what we are going to do is basically give a column name, which I'm going to give as ID, and then ID and the data type. Data type I'm going to use very common data type, integer, then comma, so that this ended. I'm not giving any constraint like not null, primary key, which we'll learn later and we will have more of that. The second one I want to give as a name, and name will be a text column. The data type which is commonly used in database is varchar, and with the varchar you have to specify a length. So data type and its length. With some of the data types like integer we don't have to specify, but here I'm specifying that it could be max 50 characters. If you try to enter more than 50 characters, you might face error. Then I'll close my parenthesis. I can give a semicolon if I like, or otherwise I can select, press F5 in this case in this studio, or simply press the execute which has been given on the menu. Now once I done, this table would be created. I can write down a select statement saying select star means select. I have to give column names. If I give star means I can get all the column names. Then next comes the from, and then the table name. The table name is demo. So select all the columns from demo and show us the result. Right now there would be no rows, so 0 rows would be written. Time has come to insert certain data. Now I will tell you the details of insert statement later, but right now just for our learning purpose, insert into, that's the two keywords you have to give, and then you have to give the table name and in the parenthesis column names. Right now we want to insert both the values, so I'm not going to give this one. I can simply write down values, and then I have to insert both the columns now, and first column is number, so I can give simply it without any double quotes or single quotes or something. But in the database, the text we give it in single quotes. So some of you are like a Power BI user like me and having a habit of giving strings or text in double quotes. We have to change a little bit. We have to give it in single quotes in database. So now I have given this, and let me insert this. Select F5 or select execute. You need to be careful. Some databases you have like simple command like control enter, and even you don't have to select and they execute one line. Some other doesn't, they might execute all the lines. So be a little careful, just select and execute. And ideally you should prefer that you don't even do that. just go ahead and execute one statement separately, or the set of statement you want to execute separately in a separate new query. And let me execute select star from demo, and it started showing me that my table has one record, and that is ID1 and name as Amit. Let me enter one more record, and I'm not going to execute both the statement I'm creating by copy paste, but I'm going to insert only one by selecting, and let me say ID2 and Sumit. Right now I'm not writing down which column I'm inserting. In the same order I'm giving the way or the order in which I created my table. I inserted another record, and let me again select it, and this time it's going to show me two records and with the two IDs and name. So this is the brief overview of what we have. We have used two kind of statement right now: create, which is data definition language, and then we have used select, which is data manipulation language. Now we will learn more about data definition language and data manipulation language. We will also learn complex SQLs. We learn how can we do data transformation, how do we normalize the table as we move forward. So watch this video. Do let me know what else you want me to cover in this particular series. Thanks for watching this video. Thank you. Keep watching, keep asking questions in comments, subscribe to my channel and press the bell icon so that you can get notification for new videos. Thank you.